All right, we are not doing any of that. We're right here. So we were doing expected value. Do y'all remember what I said expected value was? Like, what's the same thing? It's in your notes. The mean. Yeah, it's the same as the mean. So what's going to happen, and what they're going to ask for a lot of times is mean, variance, standard deviation, and then expected value. And then I already said this, but you just like copy paste that same number twice. Okay, so watch out for that. But that's where we left off. Now we're going to do this. So if you go blah, 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 what is the expected payout? So what are they asking for here? The mean. They're asking for the mean. They're asking for the average payout, the average amount that you would get for, playing, not just winning, for playing. And that's, I guess, where this problem is not fully put together. This is where it's kind of weird and we have to figure out what's going on. Okay. So we all love gambling. Gambling's awesome. And so we're picking number 1 through 25, and then you got these probabilities here, right? So you can win like a whole bunch of money, or you can win this much or this little amount. But there's another option. There's another option that they're not telling you. Isn't there some other probability here that we're missing? Like, look, we got 14%, 2%, 1%, let's say. That doesn't equal 100. What's missing here? What payment, I guess, is missing here? Take a guess. None. Zero. You can win $0, right? When you lose, basically. Or sometimes, and depending on the question, it would be a negative because you put in money for that, didn't you? So you might even have like a negative there. But yeah, that's one of the other options that we didn't put in there. But now, how do I find the probability here, right? Aren't all these supposed to be adding up to 100%, 1.0? So how would I find this amount here? Subtract. You got it. You got it. Subtract. 1 minus all these guys. And then we'll use a calculator, and then we're going to be done with this problem, really. Well, okay, I have to do more math with it, but we're going to be done with the hard part of this problem. Let me go to Desmos right quick to pull up a simple calculator right quick. Whoop, whoop, and swoop. All right, cool. All right. 1 minus 146 minus 0.025 minus 0.0006. Okay. Oh, I did it wrong. I did it wrong. Recover, Chad. Recover it. Oh, yeah, Chad, you did it. Woo! You ever do that, like on a birthday card? You're like writing, and all of a sudden you like skip a word. You're whoa. I do that all the time. Sometimes, like depending on who it is, I just like scribble through it. Other times you're like, I meant to say $0. Yeah, I know. I need to like change the fineness of this thing. $0. Yeah, that's a 0. Let me see if I can. Oh, look, I can make it thinner. Dollars. Yeah, look at that. So much better. We're gonna do thinness. Okay. Are y'all okay with the $0? So that's always an option now, right? Because we might not win anything. Now, how do I find the average? That's the bigger question now. And so I'm going to say that we go to GeoGebra for this. What I want to do is list out my, I guess, dollars and then the probability in 2 different columns. And so this is what it's going to look like. I'm going to show you, of course. 65000 and then a 0, and then we put all my probabilities right here. And then we'll just say find the mean for us, because that's what we do in this class. So geogebra.org, yeah, not .com. And I'm going to go /classic. I'll remind you about all this here in a few minutes. Spreadsheet. Pull this to the side. Okay, that'll work. So here we go. 150, $5,000, 165000, or just 0. I don't know, guys. This looks like a pretty good probability to play here. I mean, you get $150. What is that? 14% at a time. I mean, that's pretty awesome, isn't it? Okay. Now, notice what happened with this 83. It's not really 83, is it? It just rounded it on me, but that's just what is shown. See, I type it all in, so that just let it go. It's okay. It's actually still showing all that number. If you remember, we're going to go click here, one variable analysis, then the little sigma x. There's all my numbers. They want the mean, the expected value, $245.90. There you go. Cool. That was it. That's all we got to do. Is that making sense? Yeah. Is that okay? No? Let's talk. I'm here for you. Are you, is it this part right here with the 0 part? It's okay. Oh, with the GeoGebra thing, that's fine. We're going to do a lot more of that right now. It's all just clicking and stuff. Here, I'm going to go back through. I'm just going to show you. Of course, I'm recording it, right? So you can always see it like 50 times. But I just put in these numbers here into A and B, and then I just highlight them all. And at the top, there's this one variable analysis thing, which did not show up this time. Okay, well, you just click it a couple times. And then there's the sigma x button, and that's when all the numbers come up. And that's really all there is to it. They say find expected value, find the mean, find the standard deviation, find anything. That's all we've been doing at all. So yeah, there's no other place we've been doing it. Cool. So yeah, and we're going to practice a lot more even today. Yeah, even today. Yep, very good. Are y'all cool? Making sense? Okay, good. I think the hardest part with this problem is that 0 thing, because we're like, what's going on, right? We have to know what to do with this problem. All right, awesome. Oh, and I just want to say one more thing. Oh, they're going to do it here. They're going to do it here. Notice that the average payout is a positive number. Do you see that? Think about this for a second. You're a casino. Oh, really? That's awesome. So, you run a casino, and you have people paying all kind of money, and you're wanting to pay them back, right? Don't you want the average to actually be a negative? Because they're going to pay you, and you don't want to pay them back, right? On average, there's going to be some people that win, but you want to make money. Okay. Well, we're going to do that right here, okay? So we got a wheel with 38 numbers, 0, 0, 0, 1, 2, 3, all the way to 36. And someone puts down $1, and if they win, they keep the $1, and they get an additional $35. Okay. Otherwise, the $1 is lost. So I need to make a chart. I make dollars and probability. So what's one of the options for dollars? Say it again. 0. Well, not just 0, because see, they lose it. So let's say I lost. How much money would be in my wallet now? -1, right? -$1. So yeah, they're just numbering it weird. That's an extra option. Yeah, dude, I don't play that game. I don't know. It's really weird. Think of it kind of like -1. It's some things are weird out there. So yeah. Anyways, $1 could be lost, and I want to know what's that probability. We'll get to that in a minute. What about winning? So like if I won, how much would I make? $35. Exactly. I would make a positive $35, right? So I'm losing $1 or I'm winning a positive $35. Now let's find these probabilities. It says I put down money on one of these numbers, and if I get it, then I win. And so how many total numbers can we put it on? What does it say? 38? Yes, 38. You're right. There it is. 38. So I put it down on one of those numbers out of the 38. Right? 1 out of 38. I probably made it too slanted. That's kind of weird looking. Exactly. Something kind of tiny. So then what then would be for me losing? What's the opposite of this? 37 over 38. Exactly right. Yep, that's the opposite of that. And so because total here would make 38 over 38 is 100, right? So it's just the opposite there. Awesome. So they say find the expected value. What's that again? Yeah, the mean. Yeah, they're saying right here, find the mean. And so I'm going to go find the mean. Here we go. And again, this is all GeoGebra. Like I don't have to do any math in this class. That MATH stuff is not a thing here, right? Oh yeah, let's start over from the very beginning again. Yeah, let's start over. So here, I'm gonna get rid of this entirely. Like just bye bye, see you. So like I'm gonna go to GeoGebra.org, and then /classic. There's probably a button to get there. I just can't. I don't know where it is. I've tried to look for it, but GeoGebra.org/classic. So I'm gonna click it. And now it shows all the stuff. And if you don't see this little menu on the side, you'd have to click like the triple lines or one of these other guys over there. But we want spreadsheet, right? Spreadsheet. And then there's like all this stuff, but we really care only about this thing here on the side. Go ahead. You want me to go back? Yeah. Try the little triple lines on the side. Do you see spreadsheet now? Okay. Is there triple dots? Yeah. Spreadsheet. You good? Good. Okay, cool. Cool over there. Okay, it's kind of like a half work day. In just a few minutes, we're going to do some new things in GeoGebra, which I really wanted to talk about. So, okay, here's weird. I have to put in this 37 over 38 thing right here. I'm going to hit enter, and I guess it automatically does it for me. So that's kind of nice. 35, and then here I'm going to go 1 over the 38. So I'm just typing out what I have there, and it automatically computes. So that's kind of cool. And then I want to find the mean, right? So I'm going to highlight my stuff. Whatever I have, I'm going to highlight it. And then click here for one variable analysis. And then just a little sigma x thingy, little ex looking stuff. It's a sigma. It goes so, but it looks like an e. And there you go. So there, my mean, my expected value is a negative 0.0526. And this is dollars, actually. And that was it. That's the entire problem. They're saying that on average, if you keep playing enough, you keep losing about 5 cents each time. On average, you would win some, you lose some, right? But eventually, you're kind of losing like a nickel each time. So they're going to literally nickel and dime you down to your end, literally here. So pretty interesting. Cool. Good. Better. I can come to you. Sure. Yeah. Okay. Yeah. Let's get. Yep. Highlight, and then I click this little dude over here, and it should say one variable analysis. And if not, you just click it twice. And then eventually this little sigma thingy should be on the side over here. The little E looking thing. And then you click it, and there's all your numbers. That's it. Here, I'm coming to you. Very good. Oh, student. Lowercase student. Yes. Thank you. Cool. Good. That's like all we've been doing in GeoGebra at all. So like you really haven't missed anything. You're good now. That's like all we've been doing. But today is something new, so that's perfect time right now. Here we're going to do something new here in a few minutes. All right, cool. Does it make sense? It's a nice work day today. Yay. So I think that some of these are more by hand. We'll see. Yeah, I think. Oh yeah. Minus 5 cents, basically. Did you get that? Negative 0.05? Yeah. You're right, man. Right on. Yeah, perfect, perfect. So this one you want to think, oh, well, I could just put that into GeoGebra right now. And yeah, but that's not what they're asking for here. They're looking for probabilities. So they're giving us all these households and they want probabilities. So, I mean, I could look at it and say, well, I mean, that's like 300, which looks like about, half. It looks like half. I mean, could we just say that? It looks like half and we're good to go? Well, how do we find that value? How would we actually do that? Find the total. Very good. I'm going to add all these up and find out what this total is here first. So yeah, let's add them all up. And again, I'm just going to go to Desmos or something. Or you could just use your pocket calculator. It doesn't really matter. So yeah, let's add them all up, see what we get. Whoa, that was easy. 700. And so now that I have the total, what do I do with each one of these values? Yeah, divide, yeah. Put it over it, yeah. It's 297 divided by the 700. And then we're going to like get a decimal. 285 divided by the 700. It's kind of like selected over total all over again, right? Just like we were doing back in the chapter 3 stuff. So, yep. Let me go and find each one of those individually. I'll just put it on the side because I don't have enough room. Is this the rider tip? Is that like, because it used to be really like fat, now it's really thin. Is that okay? Can y'all see it and read it and all that stuff? Okay, good. I just want to make sure that I'm like making it visible and legible. Okay, yeah. I don't know how many decimal places they're looking for. It doesn't really matter. 1, 3, 4, 3. And the last one. Awesome. Cool. 4, 2, 8, something like that. I think that's my laptop freaking out over there. It's the wireless mouse, and so it like keeps turning itself off and on and off and on and off and on. Yeah. Are y'all cool with that? Yeah. Just simple calculator things, and we all have a calculator with us all the time. Whoa! Did you ever know you could do that? Wow. I probably said that at some point. They want to graph it. So is it just A, B, or C? Yeah, A, B, or C. Which one makes the most sense? Which one like closely A? Yeah, A, because it's like a whole bunch and then a little bit and then like a lot less. Because these are really close to one another, aren't they? 42 and 40. That's all. Just, yeah, multiple choice. Awesome. Do we have one more? Is it the dogs and households thing? Yep, dogs and households. And then, yeah, that's perfect. Okay, cool. Oh, which one is it skewed? Is it skewed? Which one? Skewed on the right side. Just as a reminder of what that is, it has this tail on the right side here. So a tail on the right, so a skewing on the right. That was it. Yeah, just whatever has a tail. I want to look up what a skew is. Haven't I heard that in Shakespeare? Like a skew? No, yeah? Or is it a shrew? A shrew? I'm not going to get something weird, right? We're being recorded. How do you spell it? Not Shrek. Like that? Isn't it like shrewd? Oh, look. Yeah, he's a cute little thing. Does he have a tail? I want to type in tail. Does he have a tail? He does have a tail. All right, cool. So, our shrew is skewed and he has a tail. There's his tail. Yeah. The plot thickens. They're not laughing. So, yeah, what's up? Oh, yes. Okay, actually, and I'm going to definitely record this. I'm going to tell you and everyone else here, whoever's listening on recording, this is my promise. If for some reason GeoGebra is not working. You're sitting there taking a test in the math lab. GeoGebra is not working. Something's going wrong. First, get someone over there. You need some help now. You know what I mean? And if they can't fix it, there's this X at the top, and you click it, and you walk out, okay? And I come back, I'll fix your exam. I'll make sure you can take it fully with GeoGebra. Required, okay? If it's not working, for some odd reason, you never know, right? Websites are weird like that. If something doesn't work, just walk away. We'll fix it later. You will not fail this class over technology. You get me? Not. I will not have that happen. I've had some professors, okay, some professors that say like, oh, you should know how to do it by hand. No, that's not this class. Okay, you understand me? Good, okay. So first, raise your hand and say, hey, it's not working. And then maybe they can fix it, hopefully, okay? Don't just start Xing things out and run away. But like, if they're not able to do it, I got your back, 100%. Cool? Okay, good. Okay, good. Okay, thank you guys. Very good question. That was excellent. Okay, moving on. Dogs and households, the last one here, and then we're going to start doing some crazy new stuff in GeoGebra. So it's kind of similar to what we just did, but they already did the probabilities for us. I'm guessing that if you add all these up, you're going to get 100%. Just a guess. So find the probability of selecting a household that has fewer than 2 dogs. So what is fewer than 2? And 0, 1, and 0. These guys right here, yeah? And so it says find the probability. So you could have 0 dogs, or you can have 1 dog. There it is. Or means add, right? Or means that you're going to add. So we're going to add them together. And there it is, 100%. Yeah, not 100%. It's actually like 80. But correctly worded. I know, you got to be careful in a math class like that. It's like, no, that's actually not 100%, okay? It's 87. Cool. Yeah, or means add. And so I'm saying I could have either 0 or the 1, add them up, and there you go. Cool. That was easy. It says has at least 1 dog. So what would be at least 1? 1, 2, 3, 4, 5, right? But not 0, right? So at least 1 dog. There's a dog somewhere in the house. Maybe there's more than 1 dog, but we got at least 1 dog. And I'm going to add them all up. And I know this is like the slow version, but it's always going to work. So I'm just adding all these numbers now. 0, 0, 8. Okay. Cool. 9, 7, 0, 7, 8. We got this. We're learning math. 0, 8. Okay. 3, 2, 4. I want to just confirm that this makes sense. So the probability of no dogs is 67%. What would be the opposite of that, right? Would be about 33%. So that's confirmed. And we could you have just done that, 1 minus that amount? Yes. But that's not Chad's way of doing it. Chad goes the long way every time. So yeah, I know. All right, and last one. Is this the last one there? No, there's 2 more. Find the probability of between 1 and 3 inclusive. So what numbers are 1 through 3 inclusive? 1, 2, and 3. Yeah, I know. As opposed to excluding, right? They might say the word excluding would be a little different. Just add them all up again. Cool. 0 to 6. Calculator. Here's another question that might come up in your minds. Can I have GeoGebra and Desmos up at once while taking my exam? Yes. Yes, you can, for sure. If you liked Desmos for your tiny math stuff. It does. I think you were using it earlier. Yeah, it totally works. I just prefer Desmos, maybe because I just do a lot of algebra with it. But it's for me cleaner. GeoGebra is perfectly fine though, of course, for that. Yep. Cool. Cool. Okay. Last one. Are there any that are unusual? So it's been a while since we've seen this word. There's been a while, but that's the key word there. What does unusual mean? Do you remember the percentage? What was it? Oh, okay. I know it's way, way back in the notes when we were doing the big bell curve thing back. It's probably been 3 weeks now. But just take a guess. I'm okay with a guess. I know I mentioned it in class at least. No, 5%, 5% or less. So I know I said this at some point. 95% of people are normal, are usual. So you think, oh man, I definitely know I'm weird. You're not really weird, but it's like 95% of people are totally fine or normal. So it's 5% or less that would be unusual. They're asking, do we have anything that's 0.05 or less up there? And just like individual numbers, I guess. So like, is that unusual? Yeah. There you go. Yeah. So that's 2%. That's 1%. That's not even 1%, right? These guys would be unusual unto themselves. Does that make sense? So are there any probabilities that are unusual? Yeah. I would say yes. Um, I don't know how would you put the answers here. So you would have 3 dogs, and it was 2.6%. 4 dogs is 1.5%. I don't know what they're wanting. Like, you just fill in the box and just say yes. And then we got the 5 dogs would be the 0.8%. It's like those are unusual. I don't know where they got these numbers from, but is it unusual to have 3 dogs? It is, maybe. Is it unusual to have 4 dogs? Yeah. Okay. Is it unusual to have 5 dogs? Okay. Is it unusual to have 10 dogs? No way. No, you go from 1 to 10. Duh. Yeah. So yeah, I had a student last semester. He didn't do dogs. He did snakes. Yeah, he sold snakes. That was his business. And he had to like make mice to make the snakes. And it was like this like cycle of whatever they were doing. Anyways, is that unusual? No way that's unusual. Snakes, everyone got a snake. uh, cool. Wonder if he's gonna listen now all of a sudden. He's like, I know you were talking about me. I mean, what other student could I say is like, selling snakes? Are we cool with this? No, you're not cool with this. Oh, you are cool with this? Okay. All right. I'm gonna move on, and I want to go. Hi. I want to go kind of half slow with this one again because this is going to be more like a work day on this stuff. Okay. We're going to try to use the GeoGebra because it's a brand new place, a brand new tool, lots of like moving parts. Okay, it's not what we were doing before, totally new. So binomial. Let's first off do a little bit of Latin, and I know that y'all always get this one. Okay, so bi Latin. What does bi mean? Two, like bicycle means 2 wheels, right? What does nomial mean? Now you're in statistics. Do you remember? It's spelled a little slightly different, or maybe I pronounce it different. Do you remember chapter 1? What kind of data would that be? Nominal. Nominal. Yeah? Nominal. Very similar, isn't it? And so what is nominal? Do you remember what it was? Names. Yep, exactly. Names or labels. Yep. So it's 2 names, 2 labels. Okay, that's what is going on here. I know I didn't spell it very well. 2 names, 2 labels. Let me give you what 2 names, 2 labels would be. So here we go. It's true or false, right? It's either one or the other. 2 names. We got hot and cold. Okay, I know that you got like warm in there, so that's probably not right. I don't know. I mean, but you're thinking of dualities. You know what I mean? Here's another one. We got success and failure. success, failure. Here's one. This is straight up. Cheese, no cheese. Yeah, you go into drive-through. You want a hamburger. All right, you want cheese with that? Binomial decision. Did you know that? You're doing that every time, and you're like, I want the cheese. You just made a probability happen. Yeah. No, I don't want cheese today. Cool. Does that make sense there? So two different names, two different labels, and you have to choose one of them. So that's binomial. There's a lot of other things going on here, but that's the bigger part of this. Okay, that's how we can tell what's going on here. So all of this is super important, and we're going to be putting that into GeoGebra in a few minutes. But I'm not like too. I don't have to go into this too much. I think I'm just going to go briefly. So the number of times that you're actually doing it. Let's say that you're wanting to do 10 different trials, or here, let's do it for every one of us, right? I'm going to ask cheese or no cheese, cheese or no cheese, cheese or no cheese. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 people. You get me? So that's your total, right? You would just say basically this is your total amount that you're looking at. Sound good so far? Easy enough. Now this is the probability of success, okay? P is the probability of success. And I got to use the word success in quote marks, okay? And we're going to see this as we go through this whole section, not today, but probably next time. Success is very subjective. And so here is success. How about this? Cheese or no cheese? Is it successful to have cheese? Or is it successful? Oh, definitely. Every time. But what if you really don't like cheese? My wife does not like cheese on her hamburgers. I don't know why. There it is. So see how it's subjective all of a sudden, right? I don't know what success always is. So we have to almost define it by what they say. Here's another one that's really weird. Getting heart disease. And you're thinking, that's not successful, dude. But it could be, according to the study. Very strange, okay? So don't think of it like, yes, we're doing great success. We're just saying, did you qualify for what we're asking about, you know? And again, failure would be the opposite. They got this 1 minus P business, which is really important. That's saying 100% minus the probability that you had just a second ago. So let's say I had 70% success. 70, the opposite would be a 30. If I had a 50, then it would be a 50. If I had a 20, it would be a, there he is. All opposites, right? Opposites. Is your hand raised? Yo, what's up? Yes, I can. I know. That's just so there's all those words out there. We're learning together. So what I would do, I keep clicking until I get it wrong, and then I figure it out and go back and do it right again. I know that's not the greatest answer. It's, you know, that one's a tough question. Okay. So last one, X. So X is just the number of successes. And so right here, number of successes. So we're looking for a probability. Think of it like this. We got 13 people here, and I'm going to ask you cheese or no cheese. You got me? I want to know what's the probability of exactly 6 of you saying you want cheese. Okay, so you're thinking, well, that's half, so it's got to be like 50-50. Hold up. A lot of people like cheese on their hamburgers, right? So what if I said, what's the probability of exactly 2 of you? 2 out of 13. Isn't there a probability for that? It might be probably pretty small, What's the probability that all 13 of you all say you want cheese on your hamburgers? What's the probability? It's not 100%, right? It's like somewhere in there. But we need to know, like, how many are we wanting to know want cheese or no cheese? You get me? That's the amount that it's kind of like the selected in a way, right? It's the selected. See, we got the total. That's our selected. Cool. Back to like probability times and stuff. All right. So let's go through this one here and try to figure out what they're talking about. Using all this. So decide whether it's a binomial experiment. So like at first we even got to know, is it binomial? Is it true false? Is it yes no? Is it cheese or no cheese? Let's see. So the survey was conducting asking people the question, has the economy forced you to reduce the amount of vacation this year? Now hold on for a second. Is that binomial? Is that a yes or is that a no? And that's it? Well, what's the other option? See, it says like, has the economy forced you? You could say yes, or you could say no, or you could say maybe, or you could say I don't want an answer. No response. But like, I know. Besides all that, if you have to answer, it's going to be a true or false, right? Yes or no. So 22% said that they're reducing this amount. Of the 30 people in this, what's going on? Find the probability exactly 6. You see how all these numbers are lining up for us, and it even sounds like a binomial. So here, I'm going to go through. Is this binomial? What are you going to say? Yes. It says, what is success? And oh man, here we go. This is the subjective part. They're asking, did the economy blah 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 that you have to reduce the amount of vacation? That was the question. That's success. It's successful to somehow lose vacation. Yeah. So a selected worker is reducing the amount of vacation. Like, I don't want to put X because that makes it sound bad, but like, I'm serious. This is success because that's what they're asking for. It even says right here, 22% said they're reducing it down. That's right there. That's your p-value right there. That's your probability of success. Is that a good successful thing? No, but it doesn't really matter. They're just saying that's success in this particular case. Does that make sense what I'm trying to say? Very subjective. So we don't want to think like that, okay? If binomial experiment, state the parameters. What's my total from this one? 6. I think 6 people were asking for, right? But I had a lot more workers. 30. Yeah. And so then the probability of reducing, what was that? 22. Yes, 22. And so then what would be the opposite of that? Yes, exactly right. 78. 78%. And then again, how many are we selecting specifically? The 6. Yep, you got it. And there you go. These are the numbers that we're going to put into GeoGebra in a few minutes. Like, all we do is find the 4 numbers, we put them in, we get the answer. Me too, man. I know. Been there, done that. Did I tell you all about my my government 2 class? No, I didn't tell you all that story. Oh man, I can't record that. Okay, I'll do it. Okay, just so you know, it was a summertime, and every day I come into government 2 and sit right in the very middle, and I would fall asleep every day. And he's talking about government, blah blah, and I would just fall asleep immediately. It was a great nap time for me. Awesome nap time. They were playing a joke on me one time. So everyone left really quietly and turned off the lights. And I woke up hours later, like, where is everyone? So bad. I made a C in that class, okay, and I'm never going back. So good enough. Okay, so been there, done that. Anyways, from past records, a clothing store finds that 26% of people who enter the store will make a purchase. Okay, during a 1 hour period, 18 people entered the store. What's the probability of exactly this? Does that sound binomial to you? Think about it. There it is. You're either buying or you're not. There it is. Exactly right, right? You're either going to the store and you're going to buy, or you're not. That's it. So let's do that. Exactly. You could see right here that it says the people who enter the store make a purchase. Oh, whoa, whoa, whoa. Hold on. Wait. There's a small little difference, and I'm seeing it now. I almost like need a new color here. Look right there. Do you see that word right there? Look at that. Oh, so they're giving us this probability, and it makes me feel like that's the success they're talking about. But then when they ask the question, you see in the question right here, look, the question, they're saying the ones that don't make a purchase. That's the successful ones. Isn't that so weird? And isn't that mean? That's mean, isn't it? They're like going giving you all these numbers and stuff. So success is not making a purchase. Okay. With that in mind, what's my total? And what's my selected? Yes. Now I just need to go and find those other two, right? Remember that P comes from the success, even if it sounds weird. There you go. There you go. 26. That's from the failure side. Very good. Yep. I like that. I like that. So 1 minus the 26 is that 74, like you said. Very good. There we go. Yep. And again, those are the four numbers. We're going to put them into GeoGebra and blah, 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 get whatever we want. Okay? That's going to be our goal here in a few minutes. We've got plenty of time to do it, too. Yay. Yay, Chad. I love being here. Okay. So, are we good? Rock and roll? Okay, good. This guy. A standard deck contains 52 cards. You randomly select 3 cards without replacement. What's the probability of exactly 2 clubs without replacement? Yeah. But here's the interesting part here. So without replacement, it's even emphasized a little bit. You see that? I want to have a single 1 probability. Can I actually get a single 1 probability? You see, I want 3 cards, 2 of them are clubs. So I take pick a card, any card, right? And I pull it out and I set it down. How many cards have I got left? 51. My probability has now changed, right? It used to be blah 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 divided by 52. Now it's blah 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 divided by 51. Take it out, put it down. What is it now? 50. See how it's changing? We can't put in multiple values here. It's got to be just a single number, right? It's got to be one single number, and I can't do that. Like, there's just nothing I can put there. I mean, I can put like a string of numbers, but do you think that Newton is going to understand that? No way. And so, in a way, I can't put anything here. Is this binomial? No. I know it sounded like, oh, you get a clubs or not a clubs, but things are changing on you, right? I can't say it's the same every time. But if I ask cheese or no cheese, I ask you, it's not going to change the overall probability of Americans who like cheese on their hamburgers. You know what I mean? Just asking. So yeah, not binomial, you can't do it, blah, blah, blah. Just say no. Is that making sense, the logic that I'm trying to say? Like, pick a card, any card, things are changing on you. Okay. Look at that cool formula! Oh, don't you love big formulas like that? No, nobody wants this formula, so don't do it. Ever. Okay? Don't ever. What we're going to do instead is we're going to use the GeoGebra here in a minute, but they haven't asked that yet. See, they're still saying use this tree diagram, and we're going to figure this thing out here in a minute. Yeah, looking ahead, I don't really like this kind of question, but it's okay because I want to just put it in GeoGebra. We're going to do that in a minute, but let's talk. So a card is selected from a deck and then replaced. Think about it now. Pick a card, any card, right? Blah, 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 divided by 52. I take one, I look at it, and then I put it back. Shuffle it up, pick a card, any card. Same probability, isn't it? Right? And then I pick it, and I'm like, oh, look at that. And I put it back. Shuffle, pick a card, any card. Same probability. Same probability every time, so therefore it can work. This is a binomial thing. All right, so a total of 3 times, selecting exactly 2 clubs. So let's go through some numbers before I even get started, if that's okay. What is my total? What's my total times that I'm doing this? It even says right over there. You see it? What's my total? 3? Yeah, it's 3. Yeah, exactly. And what is my selected? 2. Yeah, 2. Exactly. Now, I need to find this probability. The probability of clubs, I think. Yeah, clubs. So what's the probability of picking a clubs from the deck? A quarter, 1/4, right? 1/4 of the deck is clubs. And so you could do 1/4, or you can do like literally 25 cents, right? Because that's a quarter. So yes, very true. And again, this is not something we actually need for GeoGebra, but I need to find the Q, let's just say, the opposite. What's the opposite of 25? Yep, 3/4. I'm going to do the 1 minus thing. Hold on. We did a little formula. 1 minus a quarter is 3/4, or again, 75 cents. Okay, so those are the 4 numbers that we're going to put in to GeoGebra in just a second. And I have to do that in part B. I want to first do this part A business, okay? So draw a tree diagram. What do you talk about? Right? Well, think of it like this. I'm going to have a selection. I can have 2 different options. I can have the clubs or the not clubs. And I need to have like a probability for each of these situations. What's the probability of clubs here? Yeah, a quarter, 25, yeah. And probability of not clubs is 3/4. Okay, awesome. So I did one or the other. Here we go. So now I'm going to pick another card. So they could be clubs or not clubs. I'm going to run out of room way too fast. I'm so sorry. Can I start over right now? Yeah, just like looking ahead, that's not going to work. So hold on. Whoosh, whoosh. Okay, there we go. So I'm going to say this is club. This is not club. This is 1/4. This is 3/4. Awesome. So then from here, we got 2 more options. Club, not club. And then we got club. And we got not club. What's the probability of club? 1/4. What's the probability of not club? 3/4. Same thing as last time now, right? 1/4, 3/4. 1/4, 3/4. Chad, I'm running out of paper. I know. I'm so sorry. Here we go. Let's try one more time here. We're going to just do club and not club. C and N, C and N, C and N, C, N. Okay, there we go. So we got 1/4, 3/4, blah, 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 blah. What I need to do with this is multiply. You remember these 2 words, right? We already talked about it a little bit. Or means what again? Add. And means to multiply. So let's talk about what that means in this situation. Pick a card, any card. We got a club. Take it, put it back, shuffle. And then I'm here again with you. Again, pick a card, any card. You take it, clubs or not clubs, put it back, shuffle it. And then I ask you again, and multiply. So I'm going to actually take this line all the way down and multiply for each little trail that we can go down. Every little trail has got its own multiply for it. So here, for example, if I go down this trail right here and get to like this end, I got a club, I got a club, I got a club. 3 clubs in a row. That's pretty good, right? But then how did I get to that? So I said 1/4 times 1/4 times 1/4. Oof. If you don't mind, I'm just going to use a calculator. 1/4 times 1/4 times 1/4 is fraction action. There we go. And I don't know if we actually need the fractions or the decimals, but here, I'm going to do this anyways. 0.0156. So that's just one path, and we got a lot more. So let me try the next path. I could go down club, club, not club, right? Down the next little path to get down there. So then I'm going to multiply again, 1/4, 1/4, and then 3/4. 1/4, 1/4, 3/4 now. So now I have to go and change my little number there. 1/4, 1/4. And you can already guess, is there going to be a lot of repeats here? Yeah, there's going to be a lot of repeats for sure. But, you know, this is all just what they're trying to show here in a second. 0, 4, 6, 8. That's close enough. Just doing a rough approximation. How many more do I have to do, Chad? Well, 6 more. It takes forever. I know, right? It's basically like, I give up, bro. I'm just watching you at this point. I know. Is this what we're going to be doing for every problem? No! But it's trying to prove a point that this is why we use GeoGebra, because it's going to just give us the answer. Isn't that awesome? That's the point here to this. So let me just finish it up so I don't waste a lot of your time. So we got this path here is 1/4, 3/4, 1/4, right? So here we go. 1/4, 3/4, 1/4, and that's basically the same thing that we just had a second ago, 0, 4, 6, 8. But then this next path, I guess I'm just using alternating colors here. This path here, 1/4, 3/4, and then another 3/4, 14. Yeah, that's close enough. I know I really shouldn't keep going, but I'm going to anyways. Just stop, Chad, stop. I can't. As a math teacher, I can't. Just not finished. It's not a completed problem. Is that weird, guys? Is that a weird thing to have? Okay. Eventually, I'm going to get to the right concepts. In the meantime, how about y'all tell me a story? Come on, tell me a story. It doesn't have to be math related. They can't hear you on the other side. That was such a funny story. Yeah, that's why I like you guys. Coming up with all these funny stories that no one else can hear on YouTube. It's so funny. $406. We're so close to the end. 3/4 times 3/4 times 3/4. Last one. Here we are. See you, rip. 4218. That's close enough. Okay. Whew. Now, let's use a different color. And what I'm going to do is use the OR. I'm going to add. So it says, what's the probability of exactly 2 clubs? Does this lineup right here give me exactly 2 clubs? Are you sure about that, man? Exactly 2. Remember, how many clubs do I have for this one here? Didn't I have 3 clubs in a row? So that's no good. I don't want that one. What about this path here? Club, club, not club. Is that okay? That works. That's exactly 2. I'm looking for exactly 2. So I like this guy. Club, not club, club. That sounds good, right? Club, not club, not club. No, that was only the one club. Not club, club, club. Yeah. Not club, club, not club, not club, not club, club, not club, not club. So what I'm going to do is add those together because OR means add. I can get this one, or I can get this one, or I can get that one. And isn't it weird? Look, aren't they all the same? Look at that. Aren't they all the same? I see that now, Chad. I do. So that's 3 out of 64, and I'm going to say times 3 because there's 3 of them. Final answer. Here we go. Squeeze it in. Here we go. 0.1406 is my final answer. Or, oh, okay, that makes sense. 9/64. Here we go. Ta-da! Phew, man, that took forever. Can I just use GeoGebra now? Yes. Let's go to GeoGebra and get this done. I want to show you all the cool, neat tricks with this cool thing, okay? But are y'all seeing the answer is 14%? So when I go and do everything else, you're going to say, I got 14% and we're good, right? Here we go then. Here we go. I'm going to do GeoGebra now. We're going to do half screen. So let's do this here. We're looking for 14% in the end. Okay, So I need to get back to what I was doing because we're not doing the spreadsheet anymore. So I don't know if you want to go back to classic or if you want to just like click one of these little buttons over here that like pulls up all the different options. Okay. But we're not doing spreadsheet. We need to do probability calculator. Okay. This is the new thing. You're doing this with me now, right? This is a new thing here. We've never gone and done this before. This is the new stuff. So instead of going spreadsheet, I need to do probability calculator. So again, you can go back to classic, and then it comes right up and you do probability. Or if it doesn't show up, you can do like the triple line, triple dots, and get to probability again, okay? But when I click it, I get the bell curve. So I'm going to come around if you can't get to the bell curve. Is everyone on the bell curve? Bell curve? If not, I'm coming to you. You're on the bell curve? Thank you. Yeah, yay. Bell curve. I'm going to come. Look. You're good? Spreadsheet, that hashtag spreadsheet thing. You just get rid of that part and just I got an extra laptop if you want it, or if you're fine, you're fine. Good? Good? Here we go, guys. All right. This is a nice bell curve. Yay! And this is actually where we're going to spend all of chapter 5. We're not in chapter 5 right now. We're in chapter 4. What we need to do is go to binomial right here. It says normal. I need to click it and go down and find binomial. So it's near the bottom. Binomial. That's us right now. In the other sections, we'll be using geometric, which is not this one. It's a little different than that. And then we'll also use Poisson later. Okay, so that's all the chapter 4. But it's like with bars and stuff. And the reason why is because it's discrete probability distribution. You got to have all, like I ask you cheese or no cheese, cheese or no cheese. I'm going to get a whole number of folks that say yes or no to those. Okay, so there's my bars. I need to put in the cool numbers, and we already got these numbers. Do you see them? 3, 2, and the probability of success is 0.25. Here we go. N. What do I put in this box? Tell me. 3. My P. What goes in the P box? 0.25. And then I need to find this x equals 2 that are selected. And you can do that down here, but I would recommend actually to click up here. See it at the top of the corner? 2. What's my answer? Isn't that cool? Same number. Yeah. So all of this work, you didn't have to do it all. So Chad, why did you actually show me how to do it? Because I'm being recorded. Yeah, because all the other teachers do it, and then they're going to watch my YouTube videos and say, Chad, you're not doing it right. Now they're probably going to yell at me now. Anyways, it's just that easy. So you put in the numbers you want, you click up here. You can even change these numbers down here to whatever you want. It's done. That's it. Cool, right? Let's keep doing this. Are y'all okay with that? We good? 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 Okay. Let's do some more with that. I don't know what to put here except that we went to GeoGebra. So let's do another one. I'm gonna kind of scroll this down a little bit there. Okay. Oh, we're getting close to the end. Let's just do this one and then we're done. Is that okay? I think we just went too a little long, but that's okay. The results of a recent survey indicate that 71% of people in the United States use more than one topping on their hot dog. Oh my gosh! No, I'm just joking. Jalapenos and mustard, right? Yeah. And you're like, no. Mayonnaise? I know, right? Ketchup, right? Yeah, ketchup's a classic. Yep. Anyways, so we got 71% is a probability. If you randomly select 250 people, what's the probability that exactly 178 of them will use more than one topping? Do you see our key numbers here? So what would this one be right here? It's my total n, right? What's this exactly 178? X or selected, right? So total, selected, probability. Here we go. What goes in n? 250. What goes in the P box? 0.71. Yep. And then it says exactly 178. So you can scroll down. I recommend that, honestly. You can scroll down to 178, and there it is. You're done. That's your answer. You're literally done with that entire problem. But I want to show you a couple other options since we're still here and we got a couple minutes, okay? Like literally just a minute or so. But are y'all okay just scrolling down and clicking on it, right? Very simple. That's how it should be. That's why we're using GeoGebra in this class. It should be simple. Now, notice that they changed this down here. Later, they're going to ask, what's the probability from this to that range? And so for this, I don't think one exact answer would be really cool. But if they said, say, like from 150 to 175, something like that, some kind of range, which makes more sense on the whole scheme of things, you could see that it automatically computes it for us down to the bottom. And you can put in whatever numbers you want there. So there's also other little options here about like you can stay only on this side or that side of it, and it automatically selects. This is the without kind of thing, or outside of. All these cool options, and we'll be using those as we keep going. Good. Any questions? Pretty straightforward, right? We're going to do this a lot more. So thank you very much, guys. I'll see y'all later. Y'all have a great day.